So this piece will be first for number 3. We would have talked a little bit about it just now in the beginning of the video, and it is 6 minus x minus 2x squared. And what the question asking for is, where is this function less than k? So this function, and I just putting it for you all into perspective, right? This is the function they're talking about, right? The red function is the function 6 minus x minus 2x squared. And the question stated that this function is less than or equal to k. So where is the graph less than or equal to k? At its maximum point and below is what they're asking for. So the maximum point here, you could complete the square, or you could differentiate, put it equal to 0 and solve for your x value. You need to get the corresponding y value for the maximum point, or you could just complete the square like I said, and you're checking and see which part is the graph less than the maximum point. In this case, using GeoGebra, completing the square shouldn't be an issue for you guys. 49/8 is my answer. Cool. Alright guys, good day. So we have 2018 paper 1. Let me see how we can look it up now. Alright, so now some of these are going to be some repeat questions, so I'll still go through the solutions for them because it's been a while since I finished the playlist. Now the playlist will be in order. I'll go try and put it in order from the most recent down the road. I still have 2018, 2019, 2021 specimen and 2023 to do. So all of them will be uploaded now. Alright, so number 1, the expression AB plus 3C minus 3B minus AC is equal to, let me go ahead and see how we could factorize this. So AB, let me put the, I seen a 3 there, so let me put the 3 next to that, minus 3B plus, minus AC, because I want to put it in order. I want to put the 3's second, plus 3C. I'll get B into A minus 3. So I know it's either A or C so far. Take away C into A minus 3. So I know the next one going to be B minus C. So the answer for this is A. And I believe this is a repeat question. The linear factor of this is, now you have your calculators in paper 1s, right? So jump on your calculators for those who have their calculators like mine, and go ahead and solve this on your calculator. If you don't know how to solve a quadratic or a polynomial on a calculator, go in your booklet and see if you could figure out how to do it. Not all calculators could do it, so I'm going to do a little shortcut. Mode 23 is my shortcut for the EL506TS calculators. Mode 23 will give me the polynomial of degree 3 to solve. A is 1, B is minus 3, C is minus 3, and D is minus 4. Bam shot, I have 4 is a solution. If 4 is a solution, then x minus 4 is a factor. D is my answer. But I still want to check to see what the rest of the answers are. Now you see you have a little xy on the top here. I'll go make this a little bigger. You see this xy on the top here? This means the solutions are imaginary. Bam shot, my next solution is also imaginary. So the only real solution is x minus 4 is equal to 0. Alright, so try number 3. Number 3 looking like a piece of bacchanal because I don't know what this is. I really don't know what this is here. So I try a thing here and I'll go leave out number 3 for now. If I could figure it out, I would just put in the solutions in the video, right? Given that this is that, then f of x can be expressed, so they want us to complete the square. So I'll assemble it, minus 2x squared take away 4x plus 1. And everybody have their own way of completing the squares. My way of completing the squares is very, very simple. Minus 2 into x squared plus 2x plus half the coefficient of x, which is 1, to be squared, plus 1 take away minus 2 into 1 squared. So I'll have minus 2 into x plus 1 all squared. So minus 2 into x plus 1 all squared this is the only one that gives me minus 2 into x plus 1 all squared. So my answer gravitating towards C, but let me complete it and see if this actually is 3 over here. This is plus, there's 1 plus 2, which is 3. So C is the answer for number 4. However, you want to complete the square, you could go ahead and complete it. Or if you want, and you just get trouble completing the square, just expand out each one of these things and see what you get. When you expand out C, you will get back my 1 minus 4x minus 2x squared. A quadratic equation is such that the sum of the roots is that and the product of the roots is that. The quadratic, this is another repeat. So generally we have the quadratic being x squared, take away the sum of the roots x, and the sum of the roots is minus 2/3, plus the product of the roots, which is 3/4, is equal to 0. So x plus 2/3 x plus 3/4 is equal to 0. Multiply both sides by 12, sorry, x squared. 12x squared, 3 go into 12 4 times, 4 2s are 8. 4 go into 12 3 times, and 3 3s are 9. 12, 8, and 9. 12, 8, and 9. The answer is A. If I make any mistakes, just voice them in the comment section below, please. I mean, I am also prone to error. Given that x is greater than 0, then the set of values of x for which this is, so we have x take away 2 is less than 15 over x. Now, generally, you would like to multiply by the square of the denominators. But in this case, we could just say, let that be equal to that, and calculate the values of x. Multiply by x. X squared minus 2x. I could bring the 15 across. Minus 15 is equal to 0. And I could jump on my calculator and get my solutions. No problem at all. So quadratic is mode 2, 2. A is 1. B is minus 2. C is minus 15. My solutions are 5 and minus 3. So x is 5 and x is minus 3. Now this here is a positive x squared quadratic. So I'm looking at this here. I'm looking at minus 3 and I'm looking at 5. And I'm looking to see what the inequality was in the beginning. The inequality was a less than sign. So I'm looking at that underneath the axis. So it's between minus 3 and 5. 0. X minus 2 is less than 15 over x, which I can see. 1 minus 2 and minus 15. 5 and minus 3. Oh, sorry, they say x is greater than 0. Oh boy. See, read your questions properly, please. So x is strictly going to be good. No, they say x is more than 0. If I solve this, x could be 5 alone, right? But it will have to be d. Because think about it like this, right? X is less than 5 satisfies some solutions underneath here. But that will be 5, 4, 3, 2, 1, 0. 5, 4, 3, 2, 1. And given that the domain is x is greater than 0, we just wouldn't consider all the negative numbers, which is negative 1, negative 2, negative 3. This could never be an answer. Oh, this could be the answer here as well. X is between 0 and 5. So you go work with that. Cool. X is between 0 and 5. That's the answer. Alright, given that f of x is equal to that, the values of x for which f of x is less than 0, we have a same case here again. This is a negative quadratic. So I'll go draw my sad face. I want my two solutions and I want to see it will be a union of two disjointed set of values here. Cool, so it will be and. So let me see which is my solutions here. A is minus 2. B is 13. C is minus 6. A half and 6. So a half going here and 6 going here it's going to be the values less than a half. So x is less than a half and more than my, look at it, they're the only one that says x is less than a half. So B is my answer. Aha, this is a nice question. This is a repeat question as well. If f of x is equal to, there's a cubic polynomial and the domain is between -2 and 4, then I want to know what the range is. And it have two ways I see students attempt this, right? Now this is an easy one, but in the event that they bring a little difficulter one to do, yes, I know I use the word difficulter. Let me check and see how this graph does look. And you don't have to know how the graph does look to do it. The reason I'm going to show you all how the graph does look is so you all can see the calculations and why I'm doing the calculations. We have 1/8 x cubed. This is how the graph does look. And this graph was between -2 and 4. So let me see if I can get my graph being between -2 is less than or equal to x is less than or equal to 4. Enter. So this is what I'm dealing with for my graph. They're the only piece of the graph we are concerned with because of the domain given. I am with the rest of the graph. Alright? Now, the range of a graph is from the lowest point to the highest point on a graph. And in this case, is a simple plug in what the lowest point is, which is -2, plug in what the highest point is, which is 4, from the domain, and get my values. Now on the graph, we can do it. From the lowest point, -2 corresponds to -1, and 4 corresponds to 8. So this function, which is f of x, existing between -1 and 8. And that will be our answer over here, right? -1 and 8, which is C. But just as a contingency plan, suppose instead of this graph, I had something like this, right? Let me say plus a 2x squared. Let me say plus a 3x. Now I'm forcing an issue here, right? Because I want the graph to look a particular way. Nice. Now, the same domain, exact same domain, if I plug in the values exactly, if I plug in the -2 like I did for before, I'm going to get 1. But that's not the lowest point on the graph. The lowest point on this graph is going to be down here, which is my minimum point. So in the event that you don't have a simple graph to work with, my advice is calculate all the minimum and the maximum points. And if those minimum and maximum points existing between the domain, then those will be the values for the range. So let me translate it into the graph again for you, right? If I calculate the minimum point here, I'm going to get something down here, right? The domain of the graph is between -2 and 4. Now, given that this minimum point, the x value for this minimum point is -0 point something. Right? Let me actually get the value. The minimum point is -0.8. -0.8 is between the domain. It is inside of the domain of the graph, which means that's going to be my lowest point, granted it's a minimum point. Now, I'll go just zoom out a bit here to see what the maximum point is. I have no more turning points in between the domain, so the maximum point is going to be when x is 4. Now, it's not maximum point, it's a maximum value of the function. If you'll have any questions pertaining to this range business, just leave them in the comment section below. Number 9, f inverse x is equal to, simple algebra, I will just let y equals to 2 into x over 3 plus 5. And I don't really like how this does look, so y is equal to 2x over 3 plus 10. Interchange the x and the y's is 2y over 3 plus 10. Move the 10 across. I get x take away 10 is equal to 2y over 3. Cross multiply 3 into x minus 10. I go divide by the 2 one time now. Divided by 2 is equal to y. Let me see which one here corresponds to this. 3 into x minus 10 over 2. All right, so you see how they express this piece here as x plus 2 and the x plus 2? We could just have to fix up how the brackets does look a little bit. Now, granted, we could actually get the answer from here, right? Bam shot. Because when I put the 2 inside of the brackets here, this is 3 multiplied by a half into x minus 10. Think about it. X minus 10 over 2. It means the same exact thing. Exact same thing. But instead of putting it over 2, I will multiply by a half. Half of x is x on 2. Half of minus 10 is minus 5. Cool? If I expanded this out, and I expanded this out, I will get what I want. I will get the 3x take away 30 all over 2, which is 3x over 2 take away 30 over 2, which is 15. Multiply this out. I get 3x over 2 take away the 15. F of x is that x plus 1 over x minus 2. X is not equal to 2. F of x is, so I'm plugging in f of x into f of x. So f of x is x plus 1 over x minus 2, which is x plus 1 over x minus 2 plus 1. That is my numerator. This here was my x value, and I'm replacing all my x values with this brother man here. Over x take away 2, which is my x plus 1 over x take away 2, take away 2. I go fix up my numerator. You are supposed to do the shortcut to finding the LCM. This is going to be x plus 1 plus 1 into x minus 2, which is x minus 2, all over x minus 2, divided by x plus 1, take away, I expanded it out one time, right? When I multiply here by here, I will get take away 2x, and I will get plus 4, all over x minus 2. So I will flip my denominator and multiply. So when I flip my denominator, this becomes a numerator. This becomes a denominator. And if you all can see the shortcut here, this numerator, when I flip it, go cancel with this denominator. This becomes a denominator, and this will become my numerator for my new fraction. So I will just write that out here. I will get x plus x is 2x. 1 minus 2 is minus 1. And my denominator will be x take away 2x, which is take out negative x. And 1 plus 4 is 5. Let me see which one gives me that. X is not equal to positive 5. Bam shot. 2x minus 1 over x minus 5. We go to. Which of the following graph depicts a function? A function will pass the horizontal and well, it will pass the vertical line test. Bam shot. You pass the vertical line test. We good to go. You don't, you cut twice, you cut twice, you cut an infinite number of times. So we good to go. Alright, this is another repeat question. I'll still go through it. Working out the 3 multiplied by 27 to the m. This is 3 multiplied by 27 is 3 cubed. And 3 cubed to the power m is 3 to the power 3m. So this is 3 to the power 1 plus 3m using laws of indices. And all of this was raised to the power 1 over n. Multiply the powers. I'll get this over n to be my power. 3m plus 1 over n. Yes, I know it's a little small, but hopefully you all have a copy of this paper where you all can zoom in and see that this is actually the answer. Right? We don't have the best quality. Well, at least I don't have the best quality of papers here. The value of x, so it's 9 to the power x plus 1. At least it's looking like a x plus 1. Let me just have a little contingency plan here, and this is 2018, right? Number. I just have my, just now, I could probably go back to number, nah boy. I can't go back to number 3. It's the same copy. I just thought I could zoom into number 3 and see. Yeah, that is x plus 1. So I have 9 to the power x plus 1 is equal to 3. 9 is 3 squared. There's 3 to the power 2 into x plus 1 is equal to 3 to the power 1. Equate the powers. 2x 2 into x plus 1 is 1. 2x plus 2. Move it around. 2x is equal to minus 1. X is equal to minus a half. B is my answer. Given that log of x cubed to base 2 is equal to 6, the value of x is, well, you could use log to indice. Log to indice are carrying base power is equal to, so I'll get 2 to the power 6 is equal to x cubed. Where's 2 to the power 6, boy? Which I can't see now. 2 to the power of 6 is 64 is equal to x cubed, and just the cube root of 64. Let's work it out. Cube root of 64 is 4. So the answer here is 4. If you didn't want to do that, for those of you who know change of base, you could just use change of base here. And probably that will help you out, but the easiest way to do this one is by using your log to indice property. Root 18 plus root 50. Well, boy, me I'm gonna fight up. Root 18, I like to equal every time I have something like this, plus root 50. 11 point, and I'm gonna write it down. 3137,085. And I check in to see what each one of these things is here. 34 root 2. Nah. 6 root 15. Nah. 8 root 2. Yeah. I just entertaining it. Root 68. Nah. See, no thinking for number 15. Number 15 is a no-brainer. Now let's leave this fella here for a while. The value of x for which this is equal to 90 is... Oh, Jesus Christ. So let me just check and see what the question is here. 3 to the power x plus 2 plus 3 to the power of x is equal to 90. So this is 3 to the power x multiplied by 3 to the power of 2 plus 3 to the power of x is equal to 90. I could separate this by using my laws of indices. Now, this is 3 to the power of x into 3 to the power 2 plus 1. I factorize. That is 9 and 1 is 10. So 3 to the power x is equal to 90 divided by 10, which is 9. 3 to the power x is equal to 3 squared. X is equal to 2. So it looked like an intimidating question where we have to use logs, but we didn't have to use logs. Right? Another way I could have looked at this piece here is let y be equal to 3 to the power x. So I'm going to have 9y plus y is equal to 90. Solve for y now. 10y is 90. Y is 9. And y was at 3 to the power x. Same thing. Right? Sometimes it's easier to make a little substitution to see it a little better. Alright, so this series converges to, so we have to check and see what the sum to infinity is for convergence, right? So S of infinity is equal to A over 1 minus R, provided that the modulus of R is less than 1. So let me check and see what R is. This divided by this. 4 over 3 divided by minus 2. 4 over 3 divided by negative 2. I get negative 2/3. So my first term is minus 2 over 1 take away negative 2/3. So negative 2 divided by, good lord, negative 2 divided by open bracket 1 plus 2/3 is equal to minus 615. right? And indeed, the modulus of r indeed was less than 1. R was negative 2/3. The modulus of r was less than 1. What is the sum of the odd integers between 10 and 50? Again, it's like a no-brainer. You don't have to fight up. Let me go and add them up. Odd integers. So we're looking at 11 plus 13 plus 15 plus 17 plus 21 plus 23 plus 25 plus 27 plus 29. I will just part equal because I don't know how much more space my calculator have to put in the digits. And I'll continue with 31 afterwards. Plus 31 plus 33, just don't make a mistake. Plus 35 plus 37 plus 39 equal plus 41 plus 43 plus 45 plus 47 plus 49. 581. The sum of the odd integers between 10 and 50. Okay. 581. I feel like I missed something, you know. Or I might have seen that I missed something there, right? So, we're doing it again. Did I miss a set of numbers, boy? Or did I didn't put something? Right? Odd integers, 11 plus 13 plus 15 plus 17 plus 19. That's the first set. Equals. Plus 21 plus 23 plus 25 plus 27 plus 29 equals. Plus 31 plus 33 plus 35 plus 37 plus 39 equals. Plus 41 plus 43 plus 45 plus 47 plus 49 equals 600. I think I did miss the 33. I think. The common ratio of the geometric sequence is 12 divided by 8. Just jump on the calculator now. I like to make sure 12 divided by 8 equals 1.5 or 3/2. Alright, you can't be too safe. Alright. A sequence of positive integers is defined by that. The 10th term of the sequence is, so this is a sequence of positive integers u sub n is equal to 3 into 1/2 to the power of n take away 1. So u1 go be my first term. And u1 go be 3 into 1/2 to the power 1 minus 1, which looking like 3. I want to know what u10 is. u10 could be 3 into 1/2 to the power 10 take away 1, which is 9. Jump on your calculator and see what you get. 1/2 to the power 9 multiplied by 3. So let me put it in brackets now. 1/2 raised to the power of 9 multiplied by 3. Yes, multiplied by 3. 3 over 512. 3 over 512. The point 23 is at one end of a diameter of a circle whose equation is this. The coordinates of the other end of the diameter are ogid. Alright, so if you can't see it, draw it. That's not a circle. That's looking like a circle there. There's a circle, and let me say this is my diameter through the circle, right? One end of the diameter is 2, 3. I don't know which end it is, right? Now, I have the center of the circle here being, I could read off the center from this here, right? And the center is the midpoint of a diameter. So if I could use my midpoint formula, I could figure out what the next end of the diameter is. So I'm going to put this as x comma y. I have to read off the center from my equation of the circle. Let me read off the center. Everybody have their ways to read it off. It have 3 general equations for a circle. The x minus a into y minus b squared is r squared. The x squared plus 2fx plus y squared plus 2gy. And the x squared minus 2fx and the minus. I like to use the minus. So I have x squared minus 2 multiplied by something x plus y squared minus 2 multiplied by something y plus c is equal to 0. I will just write back the equation of the circle above this. X squared, and I will put the x next to the x and the y's next to the y's. Plus 1 is equal to 0. Now, in order for this top equation to look like the below-neath equation, I had to figure out, well, what going inside of here? It looking like 5 going inside of here to give me the minus 10. What going inside of here? It looking like a minus 1 had to go inside of here to give me back positive 2. And this here is my center. 5 comma minus 1 is my center. Some of you all would have learned this with a plus here and a plus here. And the center would just be negative this and negative this. So this is my center, which is 5 comma minus 1. So I know my midpoint formula is this plus this. So we have x plus 2 over 2, comma, y plus 3 over 2. That's my midpoint, supposed to give me 5 minus 1. This is my x value, so these two values must be equal to each other. 5 is equal to x plus 2 over 2, multiply 10, 10 take away 2 is equal to x. I get my x value to be 8, so it's either this or this. Let me check and see what the y value is. Now, we could have mitigated some working here, right? If I realize I've seen these two x values are the same thing and these two x values are the same thing. Actually, no, we can't mitigate it because in the event, I'll just show it here. Minus 1 supposed to be y plus 3 over 2. Multiply, I get minus 2. Bring the 3 across, I get minus 3 is equal to y. Minus 2 minus 3, right? Minus 5. I get minus 5 is equal to y, and I get 8 is equal to x. In the event that I do this one first, then I would have just narrowed down the answers to be D or B. I would have still had to calculate the x, but granted I calculated both of them. B is the answer. The line through the points Q and R is parallel to the line. Okay, so once I see parallel lines, I think ingredients are the same. So if parallel lines have the same gradient, I'm just gonna get a gradient at this line here. I'll go rearrange it right here now. I'll get y is equal to, and I send the 2x across, I get minus 2x. Me, I care about nothing else. The gradient is minus 2. I'll go calculate the gradient of QR, which is, let me go with this now. Let me go with this my x1 and my y1. This is my x2 and my y2 for R. I get y2, which is 8, take away y1 over x2, which is 4, take away x1, which is h, is equal to negative 2. Hit the parallel cross multiplication. 8 minus 2 is 6, is equal to minus 2 by 4 is minus 8. Minus 2 by minus h is plus 2h. Move it across. I get 14 is 2h, and h is equal to 7. Answer is D. The line y is equal to that, and the line that intersect at the point. Now, you could solve these simultaneously, or you could just trial and error your 4 answers. Now, granted that all the CD working for all of this here, I am comfortable taking it off. If you all want to see the working, you know, I could just go back in the video and watch the working. So I'll have y is equal to 2x, take away 7, and I have x plus 3y is equal to 7. Yeah, you could trial and error, but as AdMath students, I should be able to solve this pretty straightforward, right? I realize all my x coordinates here are different. All my y coordinates are different as well. So if I could get one of the x values or one of the y values, I get my answer already. Substitute this into this. I'll get x plus 3 into 2x take away 7 is equal to 7. X plus 6x take away 21 is 7. 8x is equal to 21 and 7. Sorry, 7x. Good. 7x is equal to 28 and x is 4. So the only one with x is 4 as a coordinate is A. And we're good to go. If you want to be very, very sure, just plug in 4 over here and see if you get 1 as your answer for y. 4 2s are 8. 8 take away 7 is 1. The vectors I and j represent 1 kilometer per hour east and north, respectively. Okay, so I is to the east and j is to the north. A man sails a boat on a lake such that the velocity is -1 plus 2I. Now, -1 to the east could be 1 to the west. So, the easiest thing to do this here is to just draw a Cartesian plane. And this piece of instructions here, they just put out it to tie up, right? Just work with your ij axis. -1 plus 2I. Sorry, -1 plus 2j gonna be up here. Right, that gonna be my vector. -1 and 2 when there's no current. If there is a current of 3I, then the resultant velocity v is given by, so we want the resultant vector. If I have the next vector being 3I is here. We want this resultant vector here from my understanding of the question. Let me say this is OAB. We want the resultant vector AB is equal to AO plus OB, which is -OA plus OB, which is negative -I plus 2j plus OB is 3I. So we get I plus 3I is 4I, and the only one with 4I is B. And you can check it out and see minus by plus is -2g. The wording of this question, I'm not going to lie, it's a nicely worded question. And what's going to save you here is a diagram. A unit vector parallel to this is, now a unit vector has a magnitude of 1. So I can say, well, you definitely don't have a magnitude of 1, neither do you. And if you're accustomed, right, calculating unit vectors, you will know that our C is the answer. Because a unit vector is piece of another vector. It's actually one part of the entire vector. This here is one part of the entire vector. To see the working, you just calculate the size of the vector, which is going to be 5 squared plus 12 squared, the square root. This is going to be 25 plus 144, which is 169, which is 13. This is the size of the vector. A unit vector is going to be the vector itself over the size of the vector, which is 13. Instead of having the 13 on the underneath, you can multiply it by 1 over 13. 5I plus 12j. The position vector of 2 points A and B relative to an origin O are given by that and that respectively. The modulus of AB and the angle AB makes with the x-axis respectively are that and that. So as seen here, I have 2 modulus being 10s, and I have 2 angles being 45s, and I have an angle being 30 and 90. So what I'm going to do, I'm going to draw it, and I'm going to check and see what my angle is. If I get the angle to be 30, well, I know there's my answer. If I get the angle to be 90, I know there's my answer. If I get the angle to be 45, it could either be this or this, where I have to do an additional piece of working to go ahead and calculate the modulus. So, let me draw the diagram. It don't have to be perfect. 3, 0 is going to be here. 8, 5 is going to be up here. This is OA and OB, and this is going to be, this is A and this is B. Right, so this is the vector AB. We want to know what the angle it makes with the x-axis is this angle theta. Now, some of you all might say, well, sir, we have to go and calculate the resultant vector AB. Not necessarily. All right. I know this point up here is what? 5. That is 8. And I know this point down here is 5. So I know this height here is going to be 8. And A is 3 in the first place. I know this distance here is going to be 2. So I go calculate theta by using tan inverse of opposite over adjacent, 8 over 5. Work it out, see what we get. Tan inverse of 8 divided by 5. 8 divided by 2, sorry. That is 8. That is 2. Yeah? 30 and OB is 8, 5. The angle AB makes with the x-axis is this. Yeah. I mean, I think I matched it correctly. Let me see if I make a mistake, boy. That is 8 and there is 2. It would be 8 over 5. It would be 8 over 2. Did I put tan or did I put tan inverse? Tan inverse of 8 over 2. Yeah, we still wouldn't get a nice answer. Let me just check and see what the resultant vector should be 2 plus 3, so and 0. So yeah, 2 plus 2i plus 8j. So the resultant vector going to be AB is going to be AO plus OB, which is negative OA plus OB, which is negative 30 plus 85. Oh, shucks. There's 8. There's 5. Yeah, there's 5. This distance here is 5. Jesus Christ. So tan inverse are 1. Right? So don't make that mistake. Use my mistake as a learning experience. Tan inverse are 1 is 45. Oh God. So I have no choice but to go and calculate the modulus of the vector now. So we know that all the size of the vector is 5 plus 5, which is 25, and 25 is 50. Square root of 50. Right, for those who want to see it, the vector here is going to be 5, 5, and the size of the vector is this squared plus this squared, which is 25, and 25, which is 50, and it's the square root of that. The trig expression is identical to, I think this is 2 over sine x. This was a repeat question, but it's been a while since I would have done these solutions, so let me go ahead and do it. I'll go ahead and calculate my LCM over here. I'm going to get sine x into 1 plus cos x plus sine x into 1 minus cos x divided by 1 minus cos x into 1 plus cos x. The below is a difference of 2 squares. It's 1 squared. Take away cos x squared. The denominator is going to be sine squared x. I'll get sine x cos x, minus sine x cos x here, right? So the sine x cos x cancels out, and I remain with 2 sine x's on top. If you all can't see it, go ahead and try to expand it on your own. If you still can't see it, just leave a comment in the comment section, and I go just contact you directly, and I go show you what to do, right? And the below is going to be sine squared x. So you go cancel with 1 of the sine squared. So I get 2 over sine x. Right, so my memory served me correct. Alright, the arc length in meters along the edge. So this looking like what? 45 degrees. I want to know what 45 degrees is in radians. Because they want the arc length in terms of pi. So the arc length is r theta. R in this case is 1.5, and I need to know what theta is in radians. So 45 degrees, radians has pi in it. So in order to have pi in the mix, I had to multiply by pi. And I know Radian to degree and degree to radians is some variation of pi on 180 or 180 over pi. So I want to know what is, how much times 45 could go into 180? Little bit unconventional. It's 4 times. So u into u is 4. So I get pi on 4 multiplied by 1.5. So 1.5 multiplied by a quarter. Bam shot 3 over 8 pi. Again, leave a comment below if you're having any issues. Alright, the graph of sine 2x is, alright, so I can rub off this, Sine x completes 1 revolution every 2 pi radians. Sine of 2x says, here was the seam. Now you go think that all the 2 means are spreading on the graph like this. But the 2 actually means are closing in the graph. Which means, if I close in the graph, for sure u cannot work. If I close in the graph, that means I am making 2 revolutions in every 2 pi radians. Now, how about different way we could view this, right? And how to put it, boy? If you want, all right, watch it like this, right? Yeah, we could watch it like this. Bam, 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 bam. Right, this will be here. 0, 0, 1, 0. Okay, watch it like this. Think of it as a regular graph. Whenever this is my x value, this pi, and my x value, plug this into here. From this graph, it's telling me that sine of pi is equal to, so sorry, when x is pi, y is equal to 2. Which we know not going to be true, but let me still entertain the fact, right? When x is pi, I'll get sine of 2 pi. Now we had to change the calculator into radians. Yeah. Sine of 2 pi is actually 0. So it could either be u, or u. I know it cannot be u because u is the graph for sine of pi. It can't be u either. So it has to be either u or u. Now, both of these graphs here, I am making more than 1 revolution in 2 pi radians. Cool? I am making more than 1 revolution in 2 pi radians. Over here, in D, I am making 1 revolution, 2 revolutions, 3 revolutions. I'm making 4 revolutions in 2 pi radians. You can walk. Over here, I make 1 revolution. I make 2 revolutions in my 2 pi radians. So the answer is C. Alright, I hope that explains it in a nutshell without actually diving into drawing trigonometric graphs. Right, if sine of x plus 20 degrees is cos x, the value of x is, you could trial and error this one as well, right? So let me trial and error, right? Or if you want, you could use your compound angle formula, expand out sine of x plus 20 degrees, equate it to cosine x and calculate the value of x. Alright, and we're going to do that one afterwards and see whichever one easier, go ahead. So let me check. First, I want to know what, if I move the cosine across, right? I'm going to get sine of x plus 20, take away cosine of x, supposed to give me 0. And I'm calculating this for each of these angles here and see which one gives me 0. So I have sine, change back your calculator to degrees, please, guys. Thank you very much. Let me go with 35. Sine, open bracket, 35 plus 20, close bracket, take away cosine of 35. I'll put that 35 in a bracket too, just to maintain my little, how to put, what's the word I'm looking for, boy? I don't want to say contingency. Forget, right? Let me continue. Hey! Alright, cool. Let me entertain our next angle. Instead of 35, let me use the 45. I wish I did 55 now. Alright, so I know the last one I could work, but how am I going to do this using calculations? Using the compound angle formula, this is sine x cos 20 plus cos x sine 20 is equal to cos x. Move it across. I'm going to get sine x cosine 20 is cosine x take away cosine x sine 20. Sine x cosine 20 is cosine x into 1 take away sine 20. If I divide both sides by cosine x, I will get sine x over cosine x. And divide both sides by cosine 20, I'll get 1 minus sine 20 over cosine 20. Brother man is tan x is equal to that. And x is going to be tan inverse of this piece of bacchanal here. So let me check and see what the bacchanal is first. 1 take away sine 20 equals divided by cosine 20 equals, and I'm calculating tan inverse of this. Tan inverse of my answer is 35. This is the long way around to doing the question, right? And I think everybody could agree trialing and erroring these types of questions is pretty easy. For any equations, you could trial and error it, right? For this here, you can't trial and error it because there's not an equation to work with. This is a, oh god. This was an equation to solve. The exact value of cosine of 5 pi on 12 is ogid. Now, they want it in a particular form here. So all I'm going to do, I'm going to do the same thing I do just now. Right? The same concept. Change my calculator to radians again. Cosine of 5 pi on 12. Let me check and see what that is. 5 pi on 12 is this piece of bacchanal here. I'm going to save that. For those who know how to use their storage function on the calculator, you could save this, right? But for those who don't know how to use the storage function, 258819045, I'm going to store this in A. I'm going to work out what this is first. A quarter root 6 take away root 2. Right? Yeah. So let me go with root 6 equals take away root 2 equals, and that had to divide by 4. Well, I'll be damned, man. Answer is A. Let me check the next one just to entertain it to see how we get a different answer. Huh? Root 6 plus root 2. Root 6 plus root 2 divided by 4. Now, some of you might have the question, so why does press equal sign after every time you put in, like, for example, I put root 6 then equal. Why are you doing that for? Sometimes if I have root 6 take away root 2, some calculators don't actually separate this as root 6 take away root 2. Alright? Some calculators don't. Some calculators will actually read this as the root of 6 take away root 2. This is how some calculators just read it. The root of 6 take away root 2. Where this first square root sign goes over the 6 take away root 2, which is something completely different. That is why I just press equal after every calculations for things like this. Alright, this converted to degrees is, so 8 pi over 5. We have to multiply by either 180 on pi or pi on 180. I know degrees has no pi in it, so the pi had to come here. 180 had to go here, bam bam. 180 by 8 divided by 5. 180 by 8 divided by 5. 288 degrees. Alright, so we have our next piece of bacchanal question here now. Ogid. 2 sets of compound angle formulas to work with. Alright, so Does it have any way to mitigate this boy? Sine A plus cos B is equal to... Nah, it has no way to mitigate this. One way to actually do it is actually assign some value for x and see if which one will work. That could cut down your time a lot because I'll have to use 2 sets of compound angle formulas. So I think that's what I'm going to do. These identities, they work for every single value of x you can think of. Every single value of x. A million, a billion, log 3, tan of 45. All those are values of x that could work for this. So I have sine of pi on 2 minus x. So what I'm going to do, I'm just going to pick a weird value for x just in the event that a coincidence happens. Let me pick 0.1234. That's a nice weird value for x, right? So I have sine of pi on 2. I'll go put the pi on 2 in a bracket. Pi on 2. Take away 0.1234. Close bracket. Equals, that is the sine part, plus cosine of x, which is 0.1234, plus pi on 2. Close brackets equals, this is my whole value here, right? And I'm going to write that down, 0.8693088818. What is tan of x? No. Sin x take away cos x, sine 0.1234 equals, take away cosine 0.1234 equals, no. Cos x minus sin x, cos 0.1234 equals, take away sine 0.1234 equals, this looking like it. I could just entertain the last one. 1 take away sine 0.1234, take away cosine 0.1234. Right, so the answer is indeed C. Again, if you all want to see how we expanded this out using the compound angle formula, just leave a comment below and I will contact you directly and do it. Okay, now this one, we could do the same thing here, right? We could do the exact same thing here, but it's easier to use the compound angle formula here. All right, because now we had to go and assign values, one value for alpha, and we had to check each one of these things here. Now, based on the experience with compound angle formulas, you will know this is sine 45 some many mix and a cos 45 some many mix, which translates to 1 on root 2. All right, is to decide, well, which one of these here is going to work. So, as we on the roll with the substituting and trying, let me go ahead and substitute and try, right? I could use alpha to be the same thing. Again, don't forget to change your calculator back to degrees, right? Because they like to do that. Let me go with 0.1234. Sine of open bracket 0.1234 take away 45 is equal to negative 0.7055822. I know it's either A or B. So I have sine of 0.1234. Put that in a bracket now. Sine of 0.1234 minus cosine of 0.1234 multiplied by 1 divided by root 2. I'll put that in the brackets. 1 divided by square root of 2, close brackets. 0.0055822. Now, one thing that gravitated me to this being my answer before even multiplying by this is because this gave me a negative number. And I know this here is going to give me a positive number because the cosine alpha came first. Right, I know it's not this nor this because of the fact that I have a 45 degrees here. Alright, unfortunately we can't do the same thing here. We're going to have to go ahead and differentiate this. Alright, so I'll change it into a form conformable. This is 5 take away x to the power of a half. dy dx is a half into 5 minus x. I'll take away 1 from the power, and I have to multiply by the differential of the brackets, which is minus 1. This is equal to 1 half minus a half multiplied by 1 over 5 minus x to the half, which is root 5 minus x. So it's minus 1 over 2 root 5 minus x. Minus 1 over 2 root 5 minus x. The answer is D. So the gradient on this curve, so we had to differentiate to get dy dx. dy dx is sine x, negative sine x, sorry. And sine of pi on 6. Again, change the calculator back to radians. Negative sine of pi on 6, close bracket, is negative a half, which is B. Oh, good. Alright, so seeing all of these denominators are the same thing, so I'm not going to bother to write down the denominator for my quotient rule. So my quotient rule is V du dx take away u dv dx all over v squared. I already have the v squared on my denominator for everything. So this is going to be 10 take away 2x plus 2x minus 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 going to be a minus 1. Bam bam. 10 minus 1 is 9. 9. Good to go. Alright. When I differentiate this, I get 4x. So is that this or this? When I differentiate cosine, I get negative sine. So it's going to have to be this one here. Me ain't gonna bother. How to be that? The curve C with stationary has a stationary point at this. If f double dash x is equal to x to the power of 4 take away 15, then so we're gonna check and see what the value at negative 2 is. Negative 2 plugged into here gonna give me 16. 16 take away 15 is 1. Me focusing on the number. It's a positive number, which means smiling, which means we have a minimum point. The integral of this is, oh, good. Alright, so we have 3x plus 4 to the power of 3. When I integrate this between 2 and 0, I'm doing the same thing like I did with the chain rule. I'll just treat this as a single variable only if it's linear. This is linear inside. I can go ahead and use the shortcut to the chain rule. 3x plus 4 to the power of 4 over 4. And on the denominator, I must attach the differential of this bracket alone. When I differentiate the brackets alone, I'm going to get 3. So again, 12 on the denominator between 2 and 0. Now, when I plug in 0 into this, I will get a value. So I had to plug in both ends of the limits, right? So I'm going to get 3 2s are 6. 6 and 4 is 10 over 12. That's when I plug in 2. Take away. This goes to 0. So I'll get 4 to the power 4 over 12. Now, with my calculator. 10 to the power 4 and 12. Now you see, them move so smart, man. Usually, I just given a little talk here, right? Usually, when students say 0 on the underneath, and everybody here probably guilty of it already, they just say, well, you know, that will turn out to be 0 when I plug it into my integral. And given that is a common mistake, I would have put 833 and a third as an answer here, just to tie all up. Yeah, I wicked so. Alright, nevertheless, CXC is so wicked. Take away 4 to the power 4 over 12. I'm going to put our next open bracket here. Divided by 12. Close brackets. 812. Now, I don't like how they say units squared, because this here is a straightforward integral. Yes, the application of integration is to calculate area underneath a curve, but they should have said something along the lines of this represents our area. But we digress. Hey, we're on the home stretch and not realize that. The solution for this is, oh God. So they actually didn't want us to calculate what the answer is. So I'll just go in and bring it in a form where we could go ahead and integrate it one time. So I'm going to have 5x minus 2 squared. When I'm integrating this between -1 and -4, I'm going to get 5x take away 2. I adding 1 to the power. I dividing by the power. And I had to put the differential on the denominator. So again, 15 on the denominator. So let me go and plug these things in, right? I'm plugging in -1 first. If you can mental maths it, you're good to go, right? I mean, we had to go and calculate both of them. So let me see what the first number is. We're going and get, when -1 plugging into here, I get 5 by -1 minus 2 to the power 3 divided by 15. What? Yeah. Okay. Let me plug in the next limit as well now and see if I could split it up into one of these things here. Alright, so 5x minus 2 cubed over 3. Yeah, 5 into -1. I just double checking this, right? Take away 2 to the power 3 divided by 15. Minus 3, 4, 3, 115. Alright, no scene. I will save that in A. I know the first piece. I'm going to plug in -4. Minus 2 cubed divided by 15 again. Minus 709. And it was the first number, take away this, right? So it would be A, take away my last answer on my calculator, which is 687. Am I not seeing something here? Oh, I'm not seeing something here because, pause the video and see if I could figure it out. I'm gonna tell you why I'm supposed to put a -2 on top of here. Alright, hopefully you all see that. Some of you must see was shouting at me. -2 plus 1 is -1 over -1. So this is going to be, when I bring this on the denominator, it will be 1 over negative 5x minus 2. And it don't matter where the minus sign goes, so I'll just slap the minus sign on the top. So let me see what 5 into -1 minus 2 is. That is -7. So we get -1 over, here's minus, oh, I'll divide by the differential in the brackets as well. But and I have a 5 here, right? -7 by 5 is 35. So I'll get -1 over 35. So it'd have to be one of these two here. Take away, let me see what the next thing is when I plug in. -4 over here. 5 into -4 minus 2 multiply by 5 minus 110. Now this denominator alone is -110. So this is -1 over -110, which is plus 110. And it's the first thing, take away the second thing. This is the second thing in my integral. So it's the first thing, take away the second thing, and this is positive. So the answer is D. Right, I hope that explanation was not too long, but at the same time not too short. If you're fighting up to understand what's going on for number 41, leave a comment below. Number 42, our next integration, that is limits there. That is a limit on the below. It I look into because I have a k over here. Alright, I'm going to do the same thing. This is 2x take away 4, integrating one time, right? I added 1 to the power, dividing by the new power, and I had to attach the differential of this brackets over here. So now my denominator is 8. These two have a denominator of 8, but this is the only one that has the power corresponding to this power up here. Cool. So the answer is D. A curve passes through the point 2, take negative 5. The gradient of the curve is given by that. The equation of the curve is, let me integrate. When I integrate 7, I get 7x. When I integrate x cubed, I get x to the power 4 over 4, and a plus in a c. When I integrate dy dx, I'm going to get y. I'm plugging in these points into my equation to solve for c. So this is my x, this is my y. I'll get minus 5 is equal to 7 into 2. Take away 2 to the power 4 over 4. I think 2 to the power 4 over 4 is a nice number, you know. That's just 4. So I have minus 5, bring it across, I get minus 14, bring it across, I get plus 4 is equal to c. Minus 5 minus 14 plus 4 is minus 15. So the answer is going to be A. That the only one with the constant is minus 15. Right? Oh man, we didn't even have to do that, man. 7x minus a quarter x to the power 4 minus a quarter x to the power 4. No other answer has that as my first two terms. But I didn't look at the answers. Alright, so just do as I say, not as I do. Watch the answers first and see if it could help you get your answer, right? If the integral between 4 and 1 is equal to 6, then the integral between 4 and 1 of 4, okay, cool. So I could break this up here, right? This is the integral for the integral between 4 and 1 of f of x plus 5. Now, very, very tempting to put the integral between 4 and 1 of 5. But watch where the dx ended. This dx ended here. So this is the integral I'm looking at, plus 5. So it's going to be 4 multiplied by this here, because this is the integral between 4 and 1 f of x. The integral between 4 and 1 f of x is a 6. So this is 4 into 6 plus 5. 6 was 24. 24 plus 5 is 29. And I wonder, boy, if they would have catered for this mistake to happen. This is going to be 5x between 4 and 1. So that's going to be 20 take away 5, which is 15. So we have 24 take away 15. They did cater for that mistake. Cool. So well done. Well done, CXC. Well done. Good job. Alright, so the integral of cos x minus 2 sine x. So we have the integral of cosine x. I like to do this. If I have y as sine x, dy dx is cosine x. So when I integrate cos, I get back sine. If I have y is cos x, dy is sine x, well, dy dx is negative sine x. When I integrate sine, I get negative cos. So when I integrate cosine, I'm going to get back positive sine x. So I'll write in it here, sine x. When I integrate sine, I get negative cosine. And this negative cosine here, combined with the negative sign here, becomes positive 2 cosine x plus c. So we have sine x plus 2 cos x. We have the 2 cos x, we have the sine x, and we have plus c. Alright, so that's it for 2018 solutions. Again, do this. Bam shot. Good. If I made a mistake somewhere, I humbly apologize. If you all have a question, leave it down in the comment section below. If I made a mistake and you all know the correct answer, just put it in the comments. I will just go ahead and respond in the comments and look at the comments for any corrections. I doubt I make any mistakes, right? But I am human. I am prone to error. If you learned something new, leave a like, share the video. All I've had maths just now. All right, good luck, guys. 2019 on the way.